All right, the problem is set matrix zeros. So the idea, what you're trying to do here, is you're going to go through a matrix, and pretty much anytime you find a zero, you want to set the whole column to zeros. And if you find, and you also want to set the whole row to zeros. So in this example, if we were to do this process, we'd say, okay, we have a zero here. Let's set the whole row to zero. Actually, we'll just write it over here. So we'd set the whole, hold on. So we say, okay, this guy here is a zero. So let's set this to a zero and this to a zero. Okay, one, no. Okay, we have a zero. Actually, I forgot the whole step of making the row as well. So also this, zero. Okay, now find the next zero, this one. We'd say, okay, make this whole column zeros. Make the whole row zeros, which is already done. No more zeros in the rest of it. So this is what this should look like at the end, right? Zeros, zeros, zeros. And if you look at the test case example, that's what it looks like. As you can see in this process here, I had to make a copy of the matrix, because if I just did it in place, if I just did it over on the first matrix, it wouldn't work, right? Because let's say the first zero, we make the whole column zero, and we make the whole row zero. The problem is, we then go to the next number, and we say, okay, is this a zero? And we say, well, yes, it is. So that means we make the whole column zero and the whole row zero. The problem is in the original matrix, this slot here, this element right here, was not a zero, which means in the end result, this column should not be a zero, except over here it is. So you need that copy to have one matrix that maintains the original position, so you can, or rather the original values, so you can use as a reference to know if we should make one a zero or not. And then you need the other one to actually make those changes. Now, that's pretty simple to come up with a O of m times n solution, which is just making a copy of an array. You could also, an improvement on that would be an O of m plus n solution, which the one I know of would be using a hash map. So the idea would be, for me in my solution, the idea is to have a key be a row and column, and this can be a tuple in Python, it could be a string, doesn't really matter, just have the row and column be a key. So the idea here, if we have these columns and these rows, we would start off by filling this hash table. So we'd say, okay, 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. And we put the values, the original values here. Right, so 0, 1, 2, 0, 3, 4. And this serves the same purpose as the original solution, right? This hash table is a way to remember the original positions, right? This hash table was never modified after this point. What we do is we say, okay, we don't have a copy array, so we set the single, or matrix rather, we have a single matrix. We go through each element, we say, okay, this is a 0. But what we're actually doing is not checking if this is a 0, we're checking if this is a 0. If it is, then we modify the rows, modify the columns, okay? And now you get here. And if you're checking the matrix itself, you'd ask if it's 0, and you'd say yes, because it is. But what we're actually checking, again, is over here. Was this originally a 0? No. So move on. You repeat that process. So this is an O of m plus n space solution, because this is essentially the copy matrix, just trimmed down to not take up m times n space. But that's still pretty simple. And what this is also specifically asking as a follow-up is, can you devise a constant space solution? So the way to do that, let me clear this out real quick. The way to do that, of course, if you're doing constant space, unless you could figure out a way to use a single variable or a constant number of variables, that's not the solution I know of. I don't know if that's even possible. What you want to do is use the matrix itself to store data about whatever you need, right? In this case, we're going to use the matrix itself to know which columns and which rows we should change to zeros. Now, the way we're going to do that is we're going to kind of partition off the first row and then part of the second column, or rather the first column. So what we're doing here, what each of these slots mean, right? This will hold the information for should this column become zeros at the end. This one, should this column become zeros at the end? Should this column, and so on and so forth. And this would be, would this row become zeros at the end? Should this row become zeros at the end? Now, we obviously don't have, if we do it that way, we don't have a way to store, to know if the 0th row should become 0. So we just need an extra variable for that, and that still is a constant space solution. Now, the reason this works is because at any point, let's just take this guy for example. At any point in time, if we're checking a column, if we're checking either of these elements, right, one in the same column, let's say this is a 0, and we modify this to be a 0 to say, okay, hey, later, at some point, we need to make this column a 0, all zeros. That's okay. We don't care that we lost this 1, because at this point, we had already used the 1. We had already, at the second step in the process, we said 0, okay, check this spot, then check this spot. We had already used this 1. So past that point, past this point, we don't care if we overwrite this, which is why this works. Same with the rows. Right? If you're going down here, and now you're here, we're using this 3, right? Have we use this 3? Is it a 0? No, whatever. Move on. At any point in here, we've already used this element. We don't care if we override it with information to use later. So that's the kind of intuition. So the idea is pretty much just go through each element. If a given element is 0, we'd say, okay, go to the 0th row above it, essentially the slot above it, mark this as 0. And this information means later, at the second step of the process, we make this whole column 0. We also do the same thing with a row. We say, okay, go to the 0th column, go to this guy here, right? Let me explain that better. We take the element, we say, okay, this is that 1, 1, right? We go to the 0th row of that column, which is this, mark it as 0. Reverse that process or inverse that process for the row. We say, okay, go to the 0th column, the same row, mark it as 0, okay? So this process, this algorithm has 2 steps. One is to populate the partition of the matrix that tells us what we need to do, and then apply what we need, right? So let's just run through this process. Okay, so we say, okay, is this guy 0? Yes, it is. So we need to mark the 0th element. Let's just explain that better. We need to mark this element's column top element, which of course in this case is itself. So we'd mark this as 0, which it already is. And because it's a special case, if we're in row 0, we need to apply it to this instead of this slot, because this slot, well, technically it could apply for the column or the row. In our case, we're doing it with the row. So instead of applying it here, we'll apply it here. So we'll say, okay, the row 0 needs to be zeros. Okay, next element here. Is it a 0? No. Is it a 0? No. Is it 0? Yes. Okay. So we need to set this column as zeros, which is this, and then set the row as zeros, which is this. Okay, next row. Here, is it a 0? No. Is it a 0? No. Okay, this is a bad example because there's no more zeros. Let's say this was a 0 down here. So we keep going. 0, no, no, no. Okay, this is 0. So apply the column header as a 0, and the row header as a 0. So now we have this information. So that was step 1 of the process. Mark the partitions, right? Mark all these partitions. So now that we've done that, what we can do is now work through these partitions. And we have to do this in a particular order. Because think, for example, if we used this element first to apply zeros to this row, that would overwrite this data that we need later. That would make us think that this column needs to be zeros, and this is kind of the original problem. So we need to do this in a particular order to avoid that. Now the order we can do this in, or should do it in, we should apply these rows, which is essentially the rows of 1 to the end, which, this could be 100 rows. We still would do all but the 0th row. So apply this way, apply this way, right? And now, because this data has been used, we can now overwrite it with this guy, which means apply this, apply this, apply this, if need be, apply this. So now we've used this section and this section. So now, because this data has been overridden or has been used, we can now overwrite it with the data from this, which represents row 0. So that's the order we need to do it in. The order we need to do it in is the columns 1 to the end, or excuse me, this should be rows 1 to the end, and then do columns 0 to end, and then do row 0. So the way to code this out, remember we have two steps in the process. Let me see if I can actually remember how to code this. It can get a bit messy. So first, I'm just going to make variables to make it a little cleaner later. Just the length of the matrix, how many rows we have. Same with columns. And then we also need to have this kind of auxiliary piece right here, right? This little guy that says row 0. We're going to set that as false, meaning should this row 0 be zeros? No, false. Now we want to go through and do the first step of the process, which is to mark all the spots, all the headers, the row headers and column headers with 0 if need be. So for each row, for each column, so pretty much going through each cell. Now let's first take care of our special case. Our special case is when we want to use this. And all we need to do is say if row equals 0. If row equals 0, then, well, I guess, first we want to check, actually. First we want to check if the spot we're looking at is even a 0. If it's not, we don't care about it. So if it's not a 0, we'll continue. So now, assuming it's a 0. Now, if we're in the 0th row, well, if we're in the 0th row, all we need to do is mark this guy over here, the auxiliary piece of data that represents the 0th row. We don't actually need to do anything with the columns, because if we're in the 0th row, we're already working on the headers. So for example, if this guy is 0, right, we don't need to do anything. We don't need to actually mark this header. That'd be redundant. So we can just say if row 0, and again, at this point in the code, we're assuming, because of this first if statement, that the item we're looking at is 0. We don't actually need to check that. But if the row is 0, then we just need to mark that in our little auxiliary piece. Now otherwise, if row is not 0, then that means we're down here, we're down here. So what we need to do is mark both the row header, right, this, as well as the column header. So if we were here and this was a 0, we'd mark this and we'd mark this. So we'd say matrix, we want to go the 0th row, whatever column we're at, equals 0. And then do the inverse for the row. So this first line says go to the 0 row, mark this column as 0, and then at the 0th column, mark this row as 0. Right. So this should complete our first step of the process, where we fill the information with as far as what we'll need to do later in the second step. And I'll just do a check here, see if it actually works. Now, what are we expecting with this first test case? We're expecting, if we have this first test case, at the end of the first step of the process, this should be 0, this should be 0. Output, so it should be 1, 0, 1, 0, 0, 1, and 1, 1, 1. So that looks correct. Now I'll do the second step of the process, where we use this information. So remember the order we're supposed to do. We want to do this section first, using these. Then do the column headers, which fills out all of this, and then use this. So we want to go, so we want to do the rows. So the rows in 1 to the end. So we're starting here, going here. What I'm going to do is say if matrix for the current row on position 0, column 0 is a 0, then for each column after this point, we want want to set it to 0. Do 1 to the end. Okay, so that's our first step in the second half of the process. Then we want to do the other step, which is this part up here. So for each column, and we don't have to do from 1 to 0 in this case, we just go to 0 to the end, I believe. So now we've used this partition and this partition, which means we don't care if we overwrite this data now. So we can apply this now. This is pretty simple. If 0, remember we're using a boolean here, so we don't need to check if it's equal to 0, we just need to check if it's true. If row 0, then we need to apply it to the first row. So for each column, say matrix 0 equals 0. I believe that should work, maybe, maybe not. I don't really know. Okay. Yeah, there we go. And that is a constant space solution. We are using extra space, of course, but it's no matter how big the matrix is, we're only going to use one single integer.